Okay, the floor is yours.
Okay, thanks very much. Thanks for having me and inviting me. I'm going to introduce you to JupyterLab in a very practical way today. And also, as I got from your answers on this questions via registration for your prior knowledge. So I got there isn't that much programming knowledge available here. So we start from scratch. There is no real programming knowledge needed for this course. We do everything together in a very interactive way. My goal, my overall goal for today is, and also for tomorrow, to introduce you to the tools so that we reach a level where you can start educating yourself. And okay, so just for introducing myself a bit more, who I am and where I'm from, like Andrea already told, and if you can't see anything, just tell me so I can switch sides and duck and stuff like this. Right, so about me. I'm a research associate at Leipzig University, like Andrea already told. My professional background ranged from IT system administration to studying data science a couple of years ago. And I joined the Data Science Center SCADS AI in 2019. And there my responsibilities are mainly transfer projects with industry and educational institutions, stuff like this, research and development on AI and data science, and trainings. What a coincidence, right? So I also do a bit of ID coordination for our institute. So what is our institute? I need to make this clarification with all the logos, right? Because they are sponsoring me. My workplace is the so-called SCADS AI, which is a national AI competency center funded by the German government and the Free State of Saxony. We do a lot of interdisciplinary basic research on AI, but also a lot of transfer, like transferring research results to industry, to education, to students, and also to society. Lots of it, right? So this is where I'm coming from. What we are planning for or what I'm planning to do with you for the next 2 days is this session 1, which will take place today. It's planned for 3.5 hours. Right before I planned half an hour coffee break, and we can do a 5-minute break whenever you feel like, right? It's not such a tight schedule today. And the idea is to introduce you to a couple of tools which may be helpful if you decide to work with JupyterLab, decide to work with Python tools, and decide to use AI assistants in JupyterLab, right? So this is what we are going to talk about today. And the goal is get to know your tools, like general handling of the tools and understanding. The session for tomorrow will be a bit more deep dive, not that much, but I'm going to introduce you to a couple of specific tools which may help in the data steward pipeline, like validating data, metadata creation, packaging it, loading it up to any repository like Zenodo, stuff like this. Also here again, I'm going to show you how to do it. It's not a programming lesson, right? You don't need to learn programming today and tomorrow. Besides, it would help, actually. So, right? So tomorrow is use some of the tools I'm going to show you productively. And so from this Python tool belt. Right before we start, some hints to training materials I'm going to provide you. The first one, you should already have seen it, right? Because this was linked as a preparation. You may scan this, open this in your browser, and may put a bookmark to it because we need it today, we may need it tomorrow, just to have a look, download some files again. That's this public GitHub pages where all the notebooks we are working with are rendered so that you can read them, where all the data we are working is, and the notebooks are zipped as a download so you can redo everything later on. As long as GitHub is online, this training materials will be online, right? So, and this is public accessible. The second one is an additional Nextcloud share. This is a short link. You may just type it or scan the QR code and also put a bookmark on. This is just a public share in our Nextcloud where we can put additional information on short notice where we can work together on it, right? I already put some materials and stuff there, so it would be helpful for you if you also open this website and put a bookmark there, or just make a photo of the QR code, right? Okay. Can I go on? Okay. What I like to do before doing courses is some couple of expectation management. I already started this. So we may have for this whole 2 sessions like 4 icebergs, right? The first one is Python projects and virtual environments in Python. The second one is JupyterLab and notebooks. And the third one is large language models and the use of AI assistants. And this last one is like Python programming and using Python libraries. We will scrape on all those 4 icebergs, but we can only manage to really have a look at the tips of those icebergs in those 2 sessions. But the overall goal, like I already told you, is like show you the fundamentals which help you to educate yourself later on, to redo everything by yourself, hopefully by just using all the materials I provide, right? So, what are the learning objectives for today? We want to get comfortable with 3 tools. The first one is UV. This is just a software tool to manage Python projects and Python software. That's the first one. The second one is JupyterLab. This is a browser-based interactive environment to execute and define computational notebooks, which can be used to execute code, provide documentation, print any results, plot results, stuff like this. And the third one is bia-bob. Bia-bob is a Python program or a Python library, which we can use as an AI coding assistant within JupyterLab, right? So this covers also an additional part you asked for in this short questionnaire before, right? You want to do more with AI assistants, stuff like this. So we will cover this too. Why is it called bia-bob? It's mainly developed by a colleague of mine. His name is Robert, and he's a bioimage analyst, right? So he wrote a tool wrapping AI assistant, which is specialized in bioimage analysis, and it's called Bob, right? So that's the whole magic behind this. Okay, so we want to do this in the next 3.5 hours, right? Just for the agenda, this is already done. Nice. Right now, as I got it, and that's always the case, some people don't manage to set everything up by themselves. There are problems, stuff like this. We plan like 45 minutes again just to put everything up together again so that we have a clean start with the same state for everyone on each one's laptop, right? And then I'm going to introduce you to the basic handling of this UV tool, what you can do with it, just the basic stuff. And then we go on with JupyterLab and Notebooks introduction. Then we have this very long coffee break, which is nice. And then we will play around with our AI assistant and want to use it to do some basic data exploration exercises, because this is something you may end up with as a data steward, to at least explore any data sets you are handed over with, or at least help others, educate them to do such data exploration. And you either are quite keen in programming and can use tools which do that, or, and this is what we want to do, we ask our AI assistant to draft the code, run the code. We just have a look at it, we ask if the code is correct, we ask our AI assistant to explain the code to us, like we are a beginner in Python. This is quite a helpful tool. So this is what we want to do in the afternoon, and then there's a short wrap up, and we are hopefully done at 17. Okay, any questions up to here? Great. Once again, if you have any questions, if you can't read anything, if you don't understand me because I'm speaking too fast whatsoever, just jump in, shout out loud, and we want to take a step back and slow down a bit, right? Okay, so the first thing we want to do is our technical setup check. And for this, I need to sit down a bit. Otherwise, I would stand like this the whole time. So what we want to do first is download the materials I provided. So this is a zip folder containing all the prepared Jupyter Notebooks for both sessions and such a PyProject TOML file you may encountered already in the preparation steps, right? So this is what we need for the basic setup of JupyterLab for our both sessions. So what we want to do at the first step is, okay, I need to end the presentation, of course. Here we are. Okay, so this is the GitHub Pages website, right? This may be familiar, right? So what I want you to do is open this GitHub Pages website, and from the starting page, scroll down. There you will find, I put it there yesterday evening, there you will find a new point, Notebooks. The notebooks for the practical exercises can be downloaded here. Just click on it, then a download will start, and it will download a zip file called sessions_download. If you don't find it, just raise your hand and we can go there together. It's this public GitHub Pages with the training materials.
But it's in preparation part.
Oh, you need to reload the website. Sometimes the website is cached in your browser, and this is the old version from like yesterday lunch. Doesn't help? What will help, if you open a private window in your browser, there is no cache. There should be no cache, depending on your browser.
And so now we are to download the...
Yeah, exactly. So what I want you to do is like having this landing page of the training materials, scroll down to Notebooks, click on Download it here, and it will download a file called Sessions Download, right? Great. Anyone still problems?
I think I got one problems.
Okay, so yeah, that's why I planned 45 minutes.
I wasn't able to install everything, so there's some problem here. I wasn't able to do this before, so I don't know how to fix this.
What? Oh, you weren't able to install UV.
No, because I'm not working with this, and probably I won't. So maybe I just can watch my code, and we can work together a bit.
Yeah. So as I got it, UV is not available on your laptop, right?
I don't,
Yet.
not yet.
It is.
I don't know.
It is. You are absolutely fine. UV is installed in a recent version.
Okay, so why I'm not?
So if you scroll, here, this is the landing page, right? And if you scroll down, here's Notebooks downloading. And now, right now, we are just doing a download. That's it. That's the whole magic, right? Okay, yeah. Oh, yeah, a question beforehand. Did anyone not manage to initialize his or her MetaCentrum account and issue such an API key like I described in preparations? Anyone not able to do this?
I know that the method
I don't have the key.
live, so I don't know if I did the key part. I don't remember doing the API.
Okay, so I'm going to provide my API key. I'm going to just explain why it would make sense to have your own one, because then you can use your own API key, stuff like this. But anyone else not having such a MetaCentrum account available to access this AI as a service stuff they provide for Czech researchers? Okay.
I do have the account, but I don't have the key probably. I don't know. I have the...
You may just, while I check the other problems, okay, you are registered, and then you may, here is within there's preparation, there's explained where you can, if you scroll down, where you can follow the steps explained here to create an API key, and there's everything explained. No, that's, I'm quite aware that this is something which shows up for each training. Okay, so.
So okay. Joe showed me where to download.
Yeah. Okay. Great. Okay. So everyone right now has the sessions download zip on his or her laptop. Great. Now it's up to you where you put it, but this is the folder we are going to work in for the next 2 sessions today and tomorrow. So I will put it on my desktop, right? So that I find it right away.
Should we unzip it or just in a zip?
Yeah. So put it somewhere and unzip it. No. This what I described in this preparation is just that you have a folder for testing. Yeah, we can ignore right now. We can ignore everything I wrote down in preparation because preparation is the past, and we are now in the present, right? So download this sessions download, put it somewhere you remember where you put it, and then just extract it. And then you will end up with the folder sessions download where you have, I hope you can read it. It's not, I can't put it any bigger. But we will end up with a folder called sessions download. And within this folder, there's a file, project toml, and there are 2 subfolders, session 1 and session 2, right? Great. So what I want you to do now is what I explained in preparation, right? We want to open a terminal or a PowerShell or whatsoever, depending on your laptop. We want to navigate to this folder. That's why I said remember where you put it. And then we want to use UV to initialize our project where JupyterLab is available, right? So, for example, for macOS, you can do right-click, services, new terminal, add folder. And then it depends on which operating system you are using. Bigger? Bigger? Okay. So I am right now in my terminal or PowerShell within this folder sessions download, right? Now it depends on which operating system you are working with. On Linux or macOS, it's ls to show the content of this folder. On Windows, it's dir, right? And you should up with 3 objects in this folder. Okay. Anyone not there? Sorry?
Downloading.
Okay, yes, I got it. Sometimes the wireless LAN is a bit low. We will see how this...
My husband set up it to me according to the preparation, and I am able to open this.
Yeah, exactly. This is what we did for the preparation, but this is not the prepared files for our practical session.
I don't know what to do.
Oh, yeah, this was... where's this? We can close this right now because that's we aren't that far already. Right, we can shut it down. That's all right.
Here is the terminal.
Those no. This
What are you looking for?
the starting page, right? So this is you downloaded this already?
Yes, I did.
Okay, and we want to go where this is stored.
I'm not able to do it via the terminal.
No, but somewhere, where did it save this if you downloaded it? To your... Okay, and you already did this? Great. And now I want you to open a terminal at session start. And open a terminal here. Either... it's probably this. Okay, right now you are on session 1. We want to go 1 upstairs, which is change directory ... is going 1 upstairs, right? You're fine.
Thank you.
Okay, anyone else with problems? So we all want to end up with the terminal where you are at this sessions download folder. Not in a subfolder, not in session 1 or session 2, but just there. Just show up, that's fine. Okay, so, you're on Windows. It's probably available there. So we have this. There should be something like, I'm not quite firm. This is, yeah, exactly. It's touch, right. Whatever it did. So you are now in the terminal, but we don't want to be in the terminal in the subfolder session 1. We want to be in, what does it mean?
Summer school. This Latin school is summer school.
Ah, okay, then we are wrong. We want to...
And I think I got the same.
Okay. You renamed, the folder was renamed. Not in, while unpacking, the folder was renamed from notebooks download to summer school, whatever you did, right? So we want to have, so that's fine. You open the terminal here. We want to check which files are available. This is fine. This is where we want to end up. We want to end up in the parent sessions download. Exactly. If you put wherever you put it, but it seems right, yeah. So if it's desktop, yeah. And if you now put dir and enter dir for like list what in the directory. dir. No, this is der. ir. Yeah, exactly. And hit enter. That's it. Oh no, that's not it. Because obviously.
I'm sorry, I'm absolutely not familiar.
No, that's fine. You see, we want to. Okay, you downloaded it twice into the same folder. Oh, wait a moment. I just come around.
I just unpacked it, and this is the reason.
We will do the following. We are here right now. We will remove this.
Inside.
Yeah, exactly. That's fine. We will go up one. We will delete this, and we will delete this. And we will. So now we are fine. We have this EOC SSD. We have sessions download. Here we are. We can just open a terminal here.
Here.
And if we check here we are. Okay. So, yes. That's fine. It's an interactive practical session.
Try to open it, but I'm not sure. I haven't
Oh yeah, path 2 is just because I don't know where you store it. So I'm writing path to the folder you stored. So if you store it to desktop, you need to do cd for change directory, whatever your folder name is.
So it's like this.
This does not work because we need to do probably this, exactly. Yeah. So, also, fine. Anyone else? Yeah?
I had this Jupyter alarm, so I had to stop it.
But you did download
I don't know.
and sessions?
Here.
We can just check.
Maybe 2.
Here it's sessions download on the desktop, right?
Yeah.
And you are now on the desktop. You can change directory cd to sessions download. Now you are here.
Thank you.
And you also did this double download, kind of. You downloaded the folder into a folder named the same name. So we want to put it to your desktop.
Okay.
Exactly, and we can delete this. This is something, where's delete here? And now we are going to delete everything which is kind of confusing, right?
Not. It's like it's the first.
Yeah, this is for preparation. We don't need this preparation thingy. That's all right.
But it will come.
Yeah.
Probably I'm a one step.
Thank you.
And we want to open the terminal here. And we want to check here.
There.
Here we are.
Does it mean that I'm a step?
Yeah, you are a step ahead already. So, okay, we need to catch up. Tomasz is already a step ahead. So, now everyone has a terminal open at the folder you just unzipped, and you have 3 objects, a subfolder session 1, subfolder session 2, and a file called PyProject-Toml. What we now do is using UV, the tool you already installed on your laptop, right? And you just say UV sync. And then you hit enter. This is what you did already in the preparation step to test if everything is working on your laptop. What's UV doing now is UV, the software tool, reads this file, PyProject.toml, which is a receipt for building such an environment. Then it checks which libraries, Python libraries, it shall download, for example, JupyterLab. And then it does all the download and preparation, and you should end up with no error messages and lots of libraries installed. This is the screen plus, right? So, any questions? Warning is all right. Error would be fine. Oh, this is fine. Warning is just fail to hard link files. It's just make a full copy instead of linking files, right? Okay. So this is fine. Yeah.
No idea.
This.
Sorry?
No, that's fine. Did UV sync caused by failed hard lock from. Okay. You are on a OneDrive, not on your. Okay.
My desktop is automatically.
Yeah. Okay. This is something which. Okay. This is something which may be problematic.
Okay, in the test that I did,
Yeah.
I fixed it, but I can just move it to another outside of
Yeah. It may help if you move. I'm not quite sure because I'm not using Windows and OneDrive, but it may help if you move it outside of OneDrive, right? Because this is such a cloudy thing, right? Okay, so this is what we did now, okay?
I'm still waiting.
It's still installing. Okay, while it's installing, we can just have a look at a couple of slides explaining what UV does, right? And it's in the end. So we did this Python projects with UV. So what is UV, or what is a virtual environment which UV is building on behalf of you, right? So better. There are a couple of problems if you use Python and install libraries or dependencies. For example, within a project A on your laptop, you want to make use of the Python library or tool called Pandas. I'm not quite sure if you're aware of what this is. This is just a Python library software which helps you to manage data in a tabular way. It's kind of Excel for Python, but better than Excel. And for example, for Project A, you need Pandas in version 2.3 because some of the specific functionalities are available in version 2.3. Then you may end up with creating a second project on your laptop, which by coincidence also needs Pandas, but in another version. So if you want to install both Pandas version on your laptop, in your system Python, like the Python installation on your laptop, which is like pre-installed on Mac OS and Linux and which you can install on Windows, if you do this, you must decide it's either Pandas version 2.3 or either Pandas version 3.0. It can only exist one thing, and the last one installed will override the former one, right? So this may be a problem because if you install Pandas in version 3, you can't work in Project A anymore because Pandas in version 2.3 is not available anymore. That's the core problem with having different libraries in or the same libraries in differing versions in the same Python installation, right? That's the core problem. And you can tackle this. Very smart people invented virtual environments, which is quite an easy way to solve it. We have both projects, and for both projects, we just create folders, right? And within each folder, there's a hidden folder, which you can see via this .venv. It's just a folder, and within this folder, there's a separate Python installation. There are all the libraries installed you need for Project A. We do the same for Project B, and our system Python stays untouched, right? So it's just folders on your laptop which are hidden, you can't see them, right? So this is the solution for this core problem with different Python libraries and this virtual environment. And either you do this by yourself, you create such a folder, you download Python, you install it within this folder, or you use tools which are quite capable of doing this for you. And one of them is UV. UV was created a couple of years ago. It's quite fast and very convenient by doing all this. In the end, you have this file PyProject-toml, which is the recipe. What do you want for a virtual environment and Python installation, right? And within this recipe, you just define, I want to have Python in version 3.13, for example, and I want to have all those libraries installed, which are called dependencies. For example, you can put pandas in version 2.3 in here. Now you run UV sync, which is the action on this recipe. UV reads the PyProject-toml, it builds all the libraries, it downloads the libraries to this folder, and it locks the installation. And we will end up with two artifacts. One is this hidden folder. We can just check if this folder is there, which has this isolated Python installation or the packages. And we also end up with a file UV-log, which you may see in your terminal right now if you do dir again after this installation runs through. This is just an information on which exact Python libraries in which exact version got installed on your laptop based on your operating system, right? So this is the more coarse recipe, and this is what UV actually did on your system. That's the whole process using UV, right? And the advantage right now is, let's say I'm working on a project using several Python libraries, and I want you to do the same, and I want to make sure you use the same versions. Then I can do just providing, I just provide you with my PyProject-toml, where I kind of pin versions to. I send you this file, you use UV sync, and we have the exact same virtual environment on both of our laptops. We work with the same versions of software, and we are fine with this. Any questions on how UV runs on a basic level? Okay. So, then we want to go back to our terminal. We just want to have this again to start JupyterLab. Question for the ones still running. Is it finished yet? No. Are there warnings still, or are there errors already? Oh, it's still downloading. Okay. Oh, yeah. Oh, that's the point. Okay. On this specific cases, it just downloads Python, like the programming language, which are a couple of 100 megabytes. If Python is not available on your laptop, UV realizes, oh, there is no Python. I need to download Python. And this is what takes longer.
No, in that case,
okay.
Perfect.
Great. So we will still wait, but you can catch up right now. So, and what we want to do. What we want to do now, I just cleared my screen that you can read the command. As you may imagine, with the PyProject-toml I provided you, JupyterLab was integrated already, so we can now use UV to run JupyterLab, which is what you did already via the testing. Can you read it? It's UV white score run white score Jupyter white score lab. Okay, and I want you to run this command. What's happening now in the background is UV reads all those installed libraries in this hidden folder, then realizes, oh, JupyterLab is there. I'm going to start JupyterLab based on what's installed in this virtual environment. Okay, so what's happening now is JupyterLab starts and automatically opens your default browser to show you JupyterLab. Welcome. And I see the beamer is quite... Okay. Everyone here? Not yet. Okay. If I'm too fast, just yell.
The Wi-Fi connection is so slow that it.
Okay, okay, it still downloads stuff. Okay, okay. So we still have time, right? We still have time. That's maybe the part 4 or 5 minute break, right?
There's progress
Wait a moment. I just yeah.
Some errors, so I started again.
Looks good, right? Yeah. So UV just now realizes, okay, I need to install those and those libraries. It just downloads. It may take a while regarding the internet connection, and hopefully after this you're fine. Wait a moment. A couple of yeah.
Actually, I do have some error, but I switched to this folder. But beforehand, I tried it in another folder, and it was okay. It was this.
This one we did for testing, right?
Yeah, for testing it was okay. The Jupyter. Oh, okay. There's something happening, and then in the other.
As UV run JupyterLab failed to spawn Jupyter. I don't know what I can't read this error message.
Like the policy of applications blocked this file.
Okay, now I'm not quite aware what policies like on your Windows apply. We can.
I will try.
I have the same problem because my tested data works perfectly. That's just the environment, and now this is the.
Did you also download it to your OneDrive?
It was no. It was,
OneDrive may cause problems because that's actually not on your laptop. Like it's within a Microsoft cloud where specific restrictions may be applied. So if you have the possibility to move this sessions download folder to any OneDrive folder, this may help actually.
There is also the problem with the characters in the path in OneDrive because there are some spaces and so on in the path. So sometimes.
Okay.
moving it away from OneDrive is.
Yeah. Actually, OneDrive may cause lots of issues. If you have the possibility to don't do all this don't do this on OneDrive, but it's still downloading. Yeah. I'm very sorry. I can't really accelerate the wireless LAN.
Oh, it did open, but it looks differently. There are different things.
Oh, that's fine. That's fine. I'm not quite sure where Rai is.
And also it says disk, so I'm not sure if it's not a potential issue in the future.
JupyterLab could not determine state. This is just one. No, this is fine. This is just
okay?
yeah. This is just warnings. You want to end up with what? You want to end up with this, right? Okay. Any more problems starting JupyterLab? Actually.
This.
Wait a moment. Let's Control C. Yeah, it stopped. So we need to run it again.
Sometimes it's too slow.
I mean, what helps is like really closing also the terminal, starting again from the same folder you started.
No. It was this one.
Exactly. So you don't need to do UV sync again because this is already done, right? And you may now run again UV run. Yeah. JupyterLab. Exactly. And we just see what happens. It seems like your laptop is stuck somehow. If it's still this, it may help to reboot the operating system, kind of. Yeah. So that's not really a problem. Oh, okay. It just took it. You need to kind of. Okay, yeah, and it should start right now. Oh no, it should not start now.
So I will restore it again.
The problem is use control to frozen runtime. We may.
Because
it starts and then it crashes kind of. And now the question is, what is this path you are working on? It seems odd, like this UNC ifrang sys user OPV. It seems like this is not like a local path on your hard drive, but any cloud stuff. I'm not quite sure how your laptop is managed actually. This may be a similar problem to this OneDrive thingy.
Or turn off the VPN.
This may be a point. Yeah.
My university.
Yeah.
Then
if this is possible, that's actually quite a problem. If the usage of your own laptop is such restricted that you can't even use software, it's sometimes a problem.
Okay.
Because it looks like that you are not on your own laptop. It looks like that you are on a remote drive hosted at your university.
So now I should do it again, like sync and so on, or?
You should. Can we just have a check? There should be the possibility that you use a local folder which is actually on your hard drive, not on any remote.
It's here on what? On desktop?
It depends. If your desktop is integrated in. So normally you would say, okay, the desktop is on your local laptop, but I can't tell. Like for example, if you put something on OneDrive, it also seems like it's on your laptop, but it's not. And given the path we have seen, it's not on your local laptop.
So we'll see.
So this is definitely not on your local laptop.
Okay.
Wherever this is kind of a remote drive hosted at your university.
I will copy this.
So just to recap this again, most of the problems occur if you run UV-Sync in a folder which is not actually on your laptop, which is within OneDrive, which is within any remote network drive. You can't execute stuff on a remote computer. You need to put it on your local hard drive. And now the problem is, if you can't do this because the restrictions on your university are that harsh, that's a problem. But which I can't solve because I can't unrestrict your computer, right?
So I will put it on
it's
on my laptop. And then
okay. It may be we can
this one and
okay. You may check how fast this is. It's maybe faster to just download the sessions download folder again and run UV-Sync. Maybe downloading from the internet is faster than copying on your laptop, because right now it copies lots of files within this venv. There are lots of Python files right now. Okay, so still downloading, right? Still downloading. Okay. Is it okay if we go on and I just show you around what's within JupyterLab right now, right? We are actually still in time, right? I'm quite happy that I planned 45 minutes right now. Okay, so we just started JupyterLab, right? We used UV to start JupyterLab, which was installed in our virtual environment, which is within this sessions download folder, right? Everything what's happening now is happening within this sessions download folder. Nothing else is touched on your laptop, right? So, what is JupyterLab? JupyterLab is a browser-based environment, which is quite interactive and has several components, right? The first one is, I may a bit one smaller. The first one is a file browser. This is the one here on the left-hand side, where you have a root directory, and this root directory within the file browser, you can't go up any further, right? This is where it ends. And this is the folder where you did start JupyterLab from. So within this file browser or from the view of JupyterLab, this is your root directory where you can't go any further up, right? So because if I click on this root, that's it. But I can go down, right? I can go down within any other subfolders. I can navigate like in a normal file browser. You also have like right-click with several actions you may also know from files. You can copy and paste files. You can move files to trash. You can rename them. You can open them. Stuff like this, right? So this is quite easy. We want to go up to root again, and you can for example, create a new file or a new folder, whatever you want. New file test.txt. So it's a simple file browser available within JupyterLab, which can handle all the files in the root directory, right? So here in the bigger part is your working area. Per default, such a launcher tab is open. Launcher tab just shows you the actions available within JupyterLab. For me, I can start at Jupyter Notebook, which is just such a one-pager. We will have a look at this later on, which can run Python. So this is this one. I can also start a console, a terminal, which runs Python. And all those Pythons are the Python version installed within our virtual environment, right? And if you scroll down, you also have like terminal. You can start a terminal within JupyterLab. We can do this right now. I click on terminal. Now our tab becomes an actual terminal, right? So, and we can do the same stuff we did on our terminal before. You can run, for example, ls or dir on Windows to check which files are available in this root folder. And now, not only PyProject Toml and session 2 should show up. If you use the right commands, for example, on Linux and macOS systems, I can also show hidden files, which are way more right now. You can see there's a hidden folder .venv. This is this virtual environment folder UV created, right? So this is all now living in this parent folder sessions download. So this is like we can use the terminal or open the terminal within JupyterLab again. Now our launcher is gone, right? What if I want to, yeah?
What does it mean, the ls abbreviation? I don't know, because the CD, for example, is changed.
CD is changed directory. LS is, well, I need to look it up. It's Linux specific. It does not work on Windows.
I have Windows.
Yeah. So CD is changed directory. If you want to move to another directory, I would recommend if you Google something like Windows Terminal cheat sheet. Cheating sheet, like a piece of paper. Yeah. And then cheat sheets are like listing the most common commands for anything like this. And there are overviews for terminal commands for Windows and Linux. Okay, so right now our launcher is gone. We opened the terminal. We can close it again, and then our launcher will show back up, right? So this is our working area where we can start like a terminal or Jupyter Notebook or whatsoever. We also have like this top commands, like which you may already know from any file browser, from any other software. You can do stuff with files, you can close tabs, open tabs. Very important. If you want to shut down JupyterLab, you go to File and Shut Down, right? And then it stops. It's the same like doing Control-C on the terminal. You can have view all the commands right now. Very helpful is within Help, you have Show Keyboard Shortcuts. You may start using shortcuts more often than doing stuff with your mouse and right clicks. And they are all listed here depending on your operating system. Mine may look different to yours on Windows, right? Because on Windows you maybe don't have a command key, for example, right? So this is just for the overview which components you have available in JupyterLab, right? Okay, we now want to start a Jupyter Notebook, which I already prepared. So we now want to navigate to the subfolder session. Any questions up to here, like basic components of JupyterLab? Browser-based interactive environment for managing files and notebooks, primarily. Okay, so navigate to session 1, notebooks, and we want to open the first notebook, which is called Notebook Basics. If you double click, it will open this notebook in your working area. And we can now have a look what notebooks are. Okay, so notebooks are also browser-based documents which provide 3 types of cells, right? A notebook consists of cells. One mainly used cell is a code cell where you can run and execute actual code. But the second important one is a so-called markdown cell. Anyone not familiar with what markdown is? Great. It's a language to format text, yeah, to create formatted text, right? So we have different cells in the notebook, and on which cell I'm currently which cell I'm currently working with, you can see. Right, I need to make it a bit smaller. Sorry, but you should see the same notebook on your laptop, except the guy is still downloading. I'm very sorry. Okay, so we have different cells, and if you click within, or if you click into this notebook, not into a cell, you can use your up and down arrow keys to select a cell, right? This is this bluish bar on the left-hand side. If you double-click within a cell, you see what's actually written there. So this is the actual content of a markdown cell. This is markdown syntax, right? Hashtag for heading number 1, double hashtag for heading number 2. You can do stuff like writing cursive, stuff like this. So this is the content of the markdown cell. If I want to execute it, there are several ways to do it. I can hit Command Enter, for example, but you can look it up by yourself if you just click Help and show keyboard shortcuts. And if you scroll down, you should have. That's nice, okay. You won't find it. Okay, this is the one command which is not listed there. Okay, Command Enter or Shift Enter executes the cell, right? So Command Enter executes the cell and stays at the cell. Shift Enter execute the cell and goes one down, right? So what means executing a markdown cell? Apply the formatting to the text. So what can markdown cells be used for? Documentation, for example, right? What I did right here, I'm going to explain to you what a Jupyter Notebook is and how you can use cells to do stuff, right? Okay, so this is for markdown cells. We will have a closer look at different types of how to format text later on. But we can also use the other types of cells, which are the code cells to execute Python code, and I listed it here. You can read it by your own. Also, there are also raw cells which don't get evaluated, executed. You can put any stuff like in there, for example, another programming language code which does not get executed. It's for documentation purposes, for example, where you don't want JupyterLab to execute the cell, actually, right? Okay, so let's have a look at, if you scroll down a bit, let's have a look at how to execute a code cell. Here we have again marked bluish markdown cell, which explains what's happening in the cell below. And here we have, you can also see this up here, it's Markdown. If I select the Markdown cell, if I go down, then I see code. Okay, so if I execute this cell right now, it seems to do nothing, right? But it kind of did. I will make it a bit bigger and close this. Right now, you can see, oh, that's quite, you can see that's the code cell with the code command within. If you are kind of firm with Python, we can see this is a command in Python. It does not get executed. And this is a comment. And this is a command to print something. And what do we print? Nothing, like white space right now. And if I execute the cell, you will see this. This is the output of a code cell, right? So, and since we don't print anything, output is empty, but there is an output. I want you right now to edit this code cell to print your name. If you don't know how to do it, I will show you right away. You may put your name, for example. And then I want you to execute this cell again, and you should see the according output right now. So this is what a code cell does. We can put Python code into the cell, run it, and we will be presented with the output. We can also edit it several times. And the output will change accordingly when executing this cell, right? Any questions up to here to the two different types of cells, Markdown and code? Did it work for everybody? Okay. So this is one way to use a code cell, put actual Python code into there and run it. We can also use a code cell to leave the Jupyter Notebook and run something on the underlying terminal. Right? So this is also a way to use a code cell. And this is what we can do in the next code cell. If we have this prefix exclamation mark, this tells JupyterLab, hey, whatever is written after exclamation mark, do not execute it within this cell alone, but execute it on the underlying terminal, and then give me back the result, right? We will get rid of hello Pi. This is just a small program we want to create afterwards, and do the following. You can edit this cell by yourself. We want to end up with this, right? Python ---- version. This is just to check the version of your installed Python programming language, right? And if you execute this cell right now, it will show you, okay, in my case, Python 3.13 is installed. It may differ on your system, right? So, but this wasn't executed within the cell. It was executed on the underlying terminal, and the result was played back to JupyterLab. So, why does it make sense to use it this way? I just want to show you how you normally execute Python. You normally execute Python not in such a cell, but you put Python code into a file and then you run this file, right? And we can recreate this. And oh, I already put it there. There's this file hello.py, right? You also should have it here. So if you run this code cell, the following will happen. Exclamation mark telling JupyterLab, hey, do not run this within the code cell. Do run it on the underlying terminal. On the underlying terminal, we call the installed Python programming language and tell Python, hey, there is a file called hello.py, execute it, right? And if we have a look within the file hello.py, you will see it's just the same command we had in our code cell. So there are different ways to execute code within such a code cell in JupyterLab, right? Okay, and since we now know we can execute code on the underlying terminal, we can also call UV from here. You don't need to go back to your terminal, we can do this right away here. For example, the command uv3, so exclamation mark, go outside, use the terminal, run uv3, lists all the libraries which got installed by UV for your specific virtual environment. If you execute this cell, you will end up with quite a long output. I will just make it smaller. So in my case, UV installed 127 packages, libraries, in this virtual environment to run JupyterLab and to have some additional functionalities, right? And you can scroll through all this to see what was installed in your virtual environment. If you want to get rid of all this long output, right, you can right-click on this output cell. It should be a bit dark, more dark grayish if you hover over it with your mouse. Right-click, and then you have clear cell output, right? And then the output is gone again. So you can clear output of a cell, right-click, clear cell output. Any questions up to here to executing code cells, doing stuff with the underlying terminal, clearing output of cells if you want to get rid of such long outputs which may clutter the notebook? Everything fine up to here? Not really? Okay. It just, you need to tell me, then I can make a stop, right?
So I'm still in the problem before, so now
Yeah.
it should be resolved, but it doesn't open again.
Oh no, you need to do UV run. Run. Jupyter Lab. It may take a while. And so hopefully this should work now.
Yeah.
Well, we need to wait until.
Because
yeah.
No.
And still. Okay. So I would propose that we do the following right now. Oh no, it's Windows. I don't know the command. But we are here, right? So we're going to, what is delete? I want you to delete this whole folder and run UV sync again. And we also want to delete this. Oh, and this, right?
Okay.
And then run UV sync again to reinstall everything. And then we check whether this works. Yeah. Timeout. The internet is too slow. We wasn't able to download everything. This is really, we just run it again.
Wow.
You will find everything which was downloaded already.
Okay, and we just continue.
Yeah, hopefully. Unfortunately, internet is quite slow. So all the other guys were happy that they used the good part of the internet already, right? Sorry? Oh, this may help. If you have the possibility to use a hotspot on your phone, it may be faster than the Wi-Fi here. Okay, so but up to here, everything clear about the basic usage of like markdown cells and code cells, right? Okay, if you scroll down a bit, there again I have an example of what you can do with mark. Still not?
Yeah, it looks that we win.
Come on. Yeah?
No,
It's quite disappointing. Okay, if you scroll down a bit, I provided a markdown cell with more examples, how you can add lists, numbered lists, bullet points, how you actually can link websites within a markdown cell, which really helps to document what you do in such a notebook. So, for example, such notebooks are mostly used in like data science projects where you load data, you may train a machine learning model, you try back and forth, you clean data, and all this is best documented. So you can write down, oh, I did this and this, I used this model, link the model on a website, stuff like this. So your research partners can just use this notebook to get an idea what you did and why, right? So this is what you can do with those markdown cells. And if you double click, you can see how this is actually written down, the syntax. And if you execute this cell, the formatting is applied to the text. Okay, and if we scroll down a bit, I listed those two shortcuts which aren't available in the help, which still bothers me a bit, actually. No, still not. This is wild. So I just listed it there. So you can execute cells either by Command Enter or Shift Enter. You can, if you want to switch between I'm within a cell and I want to go a level higher to switch between cells, you can just hit Escape, right? If I'm here and I hit Escape, I'm back out again without executing the cell, right? So this is something I can do. If I hit Enter, I'm within the cell and I can do writing. We leave it right now. And you can also add new cells, right? Because it would be a pity if there's a limited number of cells already predefined within Notebook. You can add as many cells with each type as you want. And you can do this by either clicking such a plus for insert a cell below, or you can use a keyboard shortcut A and B. Yeah? If you are on the level, on this higher level where you can use the arrow keys to go up and down, you can use A and B to insert cell above or below, right? So you can try it out. Just insert more cells below. You can delete cells by hitting double D. If you did delete a cell and you want to make it unhappen, you can, it should work. You can hit redo. Yeah. Bitte? Sorry. Twice, DD. Just hit the D key twice. Just hitting it once does not delete the cell. JupyterLab decided to make the shortcut DD. Yeah, sure. Yeah. Yeah, exactly. It's you hit it, you go outside, and then you hit DD, and it deletes, like
so
double D.
Outside.
Yeah, exactly. So this is inside a cell. Then most of the shortcuts does not apply. Yeah, you can just write stuff, and if you want to go outside, there are two ways. You run the cell, or three ways. This is a code cell right now, so there's an arrow. We can also make it a markdown cell. So this is one way to go outside, or if you are in here, you can just hit escape, and then all the shortcuts apply again.
Okay. So now if I click DD, it should delete. Okay.
So it's D twice.
Thank you.
Yeah. So you can play around now and just add more cells. You can switch the type of cell, like you added a code cell, you want this to be a markdown cell. You can just select it. And up here you have the type of the cell, and you can switch between code, markdown, and raw, right? And after you switch it, it's not a code cell anymore, it's a markdown cell, and text gets formatted accordingly, right? So, and if it's a code cell, we had this right away, and you put rubbish in there, which is no proper Python, and you execute it, you get, of course, an error message. The underlying Python tries to execute this cell with rubbish in it, and of course, it will complain, like name xxx is not defined, right? Okay. Any questions up to here? Does it work right now? Okay, oh, I'm quite.
So I'm here.
Oh yeah, great. Yes. So in the end, we just did all this what is explained in here. So This is a notebook right now, open with different types of cells.
Yeah.
You can see, you can switch between cells either up and down. This is on this above cell level. If you hit enter or double click in the cell, you switch into the cell and you are able to edit it, right? And if you want to get out again, two ways, either I think Control or Shift Enter executes it. In the case of Markdown, it applies the text formatting, or you hit Escape. This means leave the cell without executing.
Okay,
right?
Without
Now you are out, and this is not executed, right? And if you scroll down, everything else is explained what I just explained right now, right? So. Okay, any more questions? Then I'm going to show you one important bit, which is kind of a pitfall if you use notebooks for code, right? Okay, this is, if you scroll down, pitfalls when working with Jupyter Notebooks. So, we have a couple of cells here defined with Python code, right? We do some simple stuff. We define a couple of variables and assign a value to them. And then we print the content of those variables, right? This is what this first cell does. If we execute this cell, the following will happen. We define A and B. We assign 5, the value 5, to each variable. And then we print what's inside this variable. And here we see A is 5, B is 5. Nice. Now we do this simple math within Python. We execute this, A is A plus 1. So A and B should now be 11, right? So, but we are also able to execute a cell an arbitrary number of times, as often as we want to. So I can do this right now. And if I run this cell right now, A is A plus 1 and A plus B is 32 right now. So if someone wasn't aware that I did run this cell several times, this notebook would make no sense to this person, right? So this is something you need to remember. You can execute code cells in an arbitrary number of times, right? You can execute a code cell 100 times. It doesn't matter, but it will matter to any data analysis results, to any results where you add up things, right? You can see, if you are within this JupyterLab notebook, there's a number left to the cell. And this is the number of, or this number describes to not the number of times the cell is executed, but the, what is it? There were 32 cells right now executed in the notebook, and this cell is the 32nd one, right? So this is this number describing. And if you have a gap from, in this case, 8 to 31 or 32, you know, okay, there's a gap. One of the cells was repeatedly executed without any other cell executed, right? So this is one thing you need to remember. Number of times you can execute code cells. And the second one is you can also execute cells in an arbitrary order, right? Order doesn't matter from the view of a notebook. You can run D is 5, you can run D is 10, and now you will plot D, and D is 5 again, because I executed this first cell before I executed the printing, right? So number of executions matter, order matters, right? So, and this may be a pitfall if you do data analysis or stuff like this within a notebook. What will help in this case, if you finished your notebook with like any data exploration and like commenting and adding up stuff, you may rerun the whole notebook and tell JupyterLab, okay, please forget all the results you already have, delete them and run the notebook from beginning to end, every cell just once. And you can do this via several ways. You can either click on kernel, restart kernel and run all cells, like this is via menu and text, Or you can use this small like circle arrow. Oh yeah. Sorry? So, and this will ask you, oh, you obviously want to restart the kernel and run all cells. Are you sure? And I say, yes, of course I'm sure. And then it will restart. And in my case, it will stop at this code cell which has an error, of course. I need to delete this. And then this may take a second or two, depending on how fast your laptop is.
I'm already in.
Sorry?
I'm already in.
Yes. So everyone is up to speed right now, right? Okay, that's nice. So it still takes a while. You can see what's happening. Like right now, this upper right circle tells you what the kernel, like the running Python installation, does. In my case, it's idle. Oh, I picked the wrong icon, right? Here's restart the kernel. We want to have this fast forward, which is restart the kernel and run all cells, right? So if I do this, it restarts the kernel and then it runs all cells in the correct order, each cell just once, right? So always remember, if you have a notebook where you may end up repeatedly running cells because you want to check something, you can't remember if you did run cells in the correct order, just make sure, restart the kernel, run all cells to get rid of such pitfalls, right? This is just something you may or need to remember. Okay, so that's it for the most basic handling of Jupyter Notebooks, right? So we have our file browser on the left-hand side, where we can browse our files, of course. We can open notebooks. We can also create new notebooks, right? You can put right-click, new notebook. Then you have an empty notebook where you can start from scratch. You can rename this notebook. You can put cells in there where you can select between markdown cells for documentation or code cells for executing actual code. And that's it for now. So I think we make a short break, right? Would be good. And afterwards, we want to start with AI Assistant so that you don't need to think about writing Python code, but just let the AI Assistant do it, right? Okay, short break. Okay, welcome back. Although a couple of people may be missing, we still start with short theoretical part because we now want to, instead of doing everything by ourselves, like creating notebooks, adding cells, doing data analysis or exploration, we want to make use of an AI assistant integrated in JupyterLab, this bia-bob AI assistant, right? And since I'm going to start talking about API keys to access a large language model endpoint on a service provider, I want to explain those concepts shortly, that we are all on the same page, and you know what I'm talking about if I say we need an API key, right? And what's it for? So a short introduction to large language models and AI assistants and how they can be used. I am quite sure you all have already heard about large language models, so I don't need to go into detail any deeper. In the end, they are advanced deep learning AI models which are capable of incorporating context and interacting with users. They are trained on large amount of text and they can generate human language, understand human language. Lots of people are discussing this. And they can be used for a variety of tasks depending on their specialization, this fine-tuning training. We can train large language models not to only answer questions, but to also translate text and especially generate code. And this is what we want to use, right? And LLMs are also capable of other functions using tools like doing a web search, generating or doing more stuff than just answering questions, right? And we want to especially make use of this generating code and answering question stuff within JupyterLab. Okay, so you may also already encountered lots of different large language models and services, especially those chat interfaces from OpenAI, Anthropic, Claude, or also Hugging Face. They all provide this browser-based chat interface where you can log in and then do question answering, web search whatsoever. This can also be accessed by separate software installed on your laptop so that you don't need to use the browser anymore. So this is this chat interface. Those are all proprietary providers where you need to pay money for, but it's way nicer that there are also initiatives and services provided for researchers which can be used for free and with a way more or which are way more fitting to our needs for data protection, right? So for example, you have this infrastructure, AI as a service, where you all have created an account and potentially also already created such an API key, which allows you to access large language models which are running on a server located in Czech Republic, right? And provided by researchers for researchers, not by OpenAI for other people, right? So, but they all also they vary in like if they are used proprietary or open source, if you need to pay for them, or if they are free of charge, or they may differ where their servers are located. They all have the basic technical infrastructure and concepts, and this is what I'm going to explain right now. So how can we use such large language model services? One way I just told you was this chat interface. So this is you, right? And here we have a server or a provider server, shortened provider right now. On this server, several large language models are deployed. They are running on a GPU on server hardware, right? So we have LLM A and LLM B. There are two ways to access those large language models, make use of them. The first one is this chat interface we are already familiar with for eInfra or MetaCentrum, right? So you use your browser and you log in with your username and your password, and then you can use this chat. This is browser-based, and it makes quite hard to integrate this such a way into code or in JupyterLab or in any other AI assistant. That's why there's also a way to access those large language models via so-called API, Application Programming Interface. So this is just a way where you can access a service on a code level, right? So how can we make use of such an API? You need to log in once with a username and password. Then in your settings, this is the same for nearly all the providers, you create a so-called API key, which is just a long random sequence of numbers and characters or whatsoever. And then you can store this API key on your local PC. This is your password to access the API, and you should handle it like a password because it is one, right? Use a password manager whatsoever, keep it secure. So with this API key on your laptop, you can now run software which can, on a code level, access and use large language models by calling them via the API. So you use your API key to authenticate, log in to the API, and then use those large language models. This is what we want to do for JupyterLab. Concept is clear, right? Okay, so and to shorten this so that you don't need to write down, okay, I'm going to use the server from OpenAI located in California and I want to use the model ChatGPT 5.5, there's this shortening where you just put a provider ID like OpenAI / ChatGPT 5.5, right? This is like commonly used in the programming or data science community. Okay, so now we know how to access large language models via API, and nearly all AI assistant tools make use of it. So you may already encountered AI assistant tools, for example, Microsoft Copilot within Microsoft Office suite, or you may encounter open or AI assistants within Adobe Acrobat Reader, where right now AI assistant is constantly asking you to summarize this PDF for you, right? Those are AI assistant making use of the API, and you can integrate this way. You can integrate large language model capabilities, question answering, translating, generating code, whatsoever, in nearly any tools. You need to just provide this AI assistant wrapper, which calls the API, handles the results, and put them back into the actual application. And this is also possible for JupyterLab. And here we want to use bia-bob, which is Python program or Python software which does all this stuff. Take your question, send it via API to the provider server, take the result, give it back to you. This is just a wrapper for API access in the end, right? So we have our, oh, the beamer is nice. We have our JupyterLab front-end web UI. We have our provider, where we have different large language models available, and it gives us the access to the API, and we use our software package bia-bob as a plugin to give us the functionality to have a chat with an LLM within JupyterLab to generate code, to answer questions whatsoever, and we connect bia-bob to the API of eInfra. So this would be the shortening eInfra and a model name. In this case, one of the models is called Mini, right? So our bia-bob knows, okay, I need to connect to eInfra Mini and I need this API key. So we need to store, or we need to provide this API key to our JupyterLab environment in some way. And this is what we are going to do in the next step. 2 points left for this short introduction. Usage of AI assistants. You have already heard probably about prompt engineering, right? Prompting is just the instruction you give to a large language model, to an AI assistant, with where you expect a result or the instruction to perform a task, and you should try to formulate this task or this instruction as precisely as possible, give enough context and stuff like this, so that the large language model, the AI assistant, is actually capable of creating good results you can work with, right? Just giving a one-liner, create code which adds 2 numbers, may work, but if you provide more context, what numbers, what should the code do if there are any errors, be more specific, really helps the large language model to provide good results. Also, there are some restrictions, right? Always remember, if you connect to such a provider server, all the prompts and contexts and contents are sent to such a provider server. In our case, Metacentrum, it's a server located in Czech Republic. If you use such an AI assistant, JupyterLab, you put lots of data in there and then you connect to OpenAI. All this context information is sent to servers in the USA. Keep that in mind, right? Always think about, what is the data about? Am I actually allowed to put it on a server in the USA, right? And also, depending on which model, which large language model you choose, this defines what your AI assistant is capable of, right? If you connect your AI assistant to a very small and outdated large language model, the results are accordingly, right? There is a knowledge gap, there is like a lack of quality in responses, stuff like this. Normally, the bigger and more modern the models are, the more sophisticated they can solve tasks and the more sophisticated the answers are, but it also takes way longer to generate such answers, right? And then we have a thing called context window. Does anyone know what this is? Some are nodding. Large language model can only process a certain number of tokens. A token is a part of a word. Like if you have a sentence of 10 words, it gets split up to, let's say, 30 to 50 tokens, and this is put to the large language model. And large language models can only process a certain amount of tokens. They range from several 100,000 to a couple of million tokens, depending on the model size. But if you provide within JupyterLab a full data set, which get split up into 5 million tokens, you will run into limits of what large language models can handle. So always keep in mind, how much information, context do I actually send to the large language model? You will get presented with an error message if you put too much tokens into such a prompt. Okay, so this is just for the basic concepts. Keep that in mind when we now integrate an AI assistant into our JupyterLab. Okay. So let's go back to our JupyterLab instance, which is still open, right? Okay. You may have ended, or you may upend here. What I want you to do is, yeah, sorry? Sorry?
I was asking where is the water?
Ah, okay, yeah, so I don't know. Yeah. Okay, so what I want you to do is open session 1 notebooks, notebook number 2, AI Assistant Basics. If you double click on it, it will open in your working area. Here again, lots of text, mostly what I explained already. And we want to make use of bia-bob here. I also linked the website to the GitHub repository where all this is explained in detail. If you want to have a look at the code, just do it. And we now want to provide our AI assistant, which was already installed via UV, right? It's listed in the PyProject TOML. There's bia-bob written down, so it's already installed. And to some point, we need to now provide our bia-bob with the API key. How can we check whether such an API key is already there or not? We can do this in such a code cell. If you scroll down a bit, I listed several commands which help you to investigate all the available so-called environment variables. What is an environment variable? It's just a variable or a content, data, whatsoever, available in memory right now for your virtual environment, right? So something which is written down and constantly available in memory. So I want you to check on your laptop right now which environment variables are available. So we can do this in this next code cell. Here's to do, check the available envs, and we want to use a so-called IPython magic command. You already encountered the exclamation mark, right? Which tells JupyterLab, run this on the underlying notebook terminal and then give back the result. Another special character is %, which is specific to interactive Python, which is the core of JupyterLab. This is just another way to execute commands, but this is operating system agnostic. So it doesn't play a role if you're on Windows, it doesn't play a role if you're on Linux or Mac OS. It always works because IPython handles all the other stuff. So what we can do now is use this code cell, put $env for environment, and execute this cell. So, and now in the cell output, you get a list of all environment variables which are currently available on your laptop in your active virtual environment right now. I can make it a bit bigger. So, they will differ from laptop to laptop right now. So, for example, on my laptop, there is an environment variable. It's always key colon value, right? So I have a key for home, and my home on my laptop is the path users Matthias, right? And there you have a full list of all available environment variables. And bia-bob is capable of reading this list and getting our API key from it once we put it there, right? So, because what I want you to check right now, in this list, is there a key which is called open_AI_API? I don't think so, because we didn't put it there. But we want to, we want this environment variable to show up here, right? So basic concept of providing an API key to such an AI assistant, write it to an environment variable and make it available here. So how can we do this? We can, any questions up to here? I know it's a lot of text right now, but I just want to show you how you can check if there's an environment variable available. You can check whether a specific environment variable is available by putting the name to it. In this case, I can check whether the environment variable with the name endpoint URL is available or not. In this case, IPython tells us, oh no, there is no such environment variable, but we need it. So, okay, to do this, to create and provide such variables we need, and those are two. We need the URL to the provider server API, right? And we need the API key. Those are both environment variables we want to provide. And we can do this by creating a file where those are stored and then starting JupyterLab reading this file. And then they are available. We can do this, or we will do this together right now. So what I want you to do right now is open the file browser. Click on the root folder, so that you are in the root directory of this virtual environment where you see session 1, session 2, PyProject, TOML, all the other files. Now we want to create a new file. You may name it whatever you want. I recommend to name it secrets right now because it will hold our secrets. API key is a secret, right? So right click, new file, secrets. Important, do not write .txt, just secrets, no file ending, right? Can you see it? We can open it, it is empty, right? So, and two ways, I can just type everything and you type after me, or we copy paste, and that's why I prepared this Nextcloud share. And if you open this Nextcloud share again, where you hopefully have a bookmark for, there is a file secrets prepared already. And if you open this, you can just copy the whole content via this icon here. Did you find the secrets file in share? Sorry? That I provided two QR codes in the beginning. There's this Nextcloud share I provided in the early beginning, like training materials. No, that's not the one. I provided two QR codes where I told you to open it and put a bookmark there. We can, if you open this again, we need the, go here and landing page. There are the slides provided here. Those are the slides I showed you. You can open it. And if you scroll down a bit, here. This is the one you have open right now. We need this. You can just copy paste this. Exactly. Yeah.
Should we put in our own API key?
This is something I just talk about. I'm going to talk about. Yeah. Right now, you see there's lots of content. We just do copy paste to your own secrets file in JupyterLab right now. Yeah. So open the Nextcloud share, open the secrets files, copy the whole content, copy, then go back to JupyterLab and paste it here. Then you have the full yeah.
So you are still not there with the secrets, all of us. Where can we find it?
This is not this Nextcloud share. If you scroll down a bit, up. So those are the slides I showed at the early beginning where I provided two links.
We didn't get it.
Okay, then just store it somewhere. We want to open the we want to open the slides because there are the links hosted, written down.
It looks something.
Yeah, so, yeah, exactly. So you need to store it somewhere and open, it's a PDF, like it's the slides I showed at the beginning, right? No, now you need to open the slides because this is what I showed, exactly. And if you scroll down, so those are the GitHub page. No, those are the GitHub pages you had open right now, and the other one is this Nextcloud share I provided.
Where it was? Oh my gosh.
Lots of tabs.
Yeah. Sorry.
Exactly. Scroll down a bit. This is the Nextcloud share,
This one.
and you may put it into a bookmark because we may need it later on. We may need it tomorrow, and it just takes a while. It's forwards to a Nextcloud we have at our institute. Exactly, and there's this file. It also takes a while. There's this file secrets. And here you can just copy the whole content, go back to your Jupyter lab.
Where is it?
I don't know. Exactly, and just paste. Great. So, okay, now you need to store the content. You may see or see not. Once you change contents of a file, this small cross changes to a dot, right? So, and if you haven't done it already, you need to store the content, either file save or command S for storing. Those are basic file commands, right? And we end up with the secrets file within your folder, which has the following content. It kind of uses markdown syntax, so everything with a hashtag is a comment, and this is just structured comments. But we have several environment variables provided in this file. The first one is endpoint URL is, and then the URL to the API endpoint of e-infra metacentrum, blah, blah. This is where you can reach the API. The second one is a so-called OpenAI API key. Why is it named this way? Because OpenAI started providing API access. That's why the whole world named this environment variable OpenAI API key. It's compatible to everything which resembles OpenAI API. Here I put mine API key. You may put your API keys there. You can also use mine, but mine will be not valid anymore like next week because I'm not a Czech researcher, right? So API key starts with SK minus something something. So you may remove this. This you can't really see this on this beamer, right? So OpenAI API key is, and then you put your own one, starting with S key minus something something, right? This is the API key our bia-bob will read from environment variables.
And this is from the account that we should perform?
Exactly. So as a Czech researcher, you can apply for such a Metacentrum account. And with such a Metacentrum account, you can initialize or apply for access to the AI as a service, large language models. And once you are logged in, you can create such an API key. All this is described in my preparations stuff thingy, and also in detail on the how-to pages from Metacentrum. And there's a third environment variable, which I called system prompt data steward. This is for later on. We just ignore it for now, but this will also be provided right now. So we now have our secrets file. What do we do with this? We want JupyterLab to load this file when JupyterLab starts. For this case, we need to end JupyterLab right now. We want to restart JupyterLab, right? So first of all, file shutdown. So we are now shutting down JupyterLab. with the goal to restart it, but for this next restart, you just now get this server stop, blah, 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 because JupyterLab is down. You don't have access anymore to it via browser. So what we want to do right now is go back to our terminal. I assume some of you don't have it open anymore. So what you want to do, we just stopped JupyterLab. What we want to do now is open your terminal, go back to the sessions download folder we worked in the whole time. And if you are there, you can check either via ls or via dir on Windows whether the secrets file is there. Yeah, we want to have this folder where the secrets file is. And if you are there, I want you to run JupyterLab again, but with an additional command. We say uv run, and now we tell uv to use an environment file, which is called secrets, to start JupyterLab. And this looks like this, --- file. Oh, I need to check. Secrets, JupyterLab. So this command calls uv and tells uv to run JupyterLab, but now use this environment file called secrets to run JupyterLab, right? Yes.
Why we need to work in this environment?
In which environment? We want to provide this environment variables, this API key. Okay. Yeah. Yeah. So, because we within the secrets file we defined the API key content, and this is loaded once we load this file, right? Okay, great. Just ask questions. I'm here to answer questions, actually. Yeah.
We don't know what to do. I wrote this, but I don't know what I did.
LS does not work on
Windows?
Yeah, exactly. This is yes. So no, that's fine. So yeah, exactly. This uv run --env file. So if you run this command, JupyterLab should show up again on your system. I still leave it on here. If it does not work on your, just raise your hands and I can just double check.
I'm sorry.
No, that's fine.
I have here this sign. I don't know how to. Yeah.
What does it do?
Now. Okay.
No. This is not env ---- file, but --env file. I'm sorry. That is yeah. So you have double minus, which is not recognized.
But instead of I have this percentage, I have this sign.
Yeah, because
okay.
This is Windows terminal and this is Mac terminal, so they just use different signs. So, but this should help. Yes. Yeah. It's ---env file. So I'm just and UV unexpected argument.
So maybe
What?
somewhere else.
Sure. Okay, so secrets seems to be empty. Did
Say it?
Yeah, you probably didn't store the contents in the secrets file, right? We can just double check. Yeah, okay, so this can't be here. This is something you accidentally put there, which is okay. We just store it right now. I let you do it again. Just shut down JupyterLab and restart it like we just did. Okay, anyone else with problems? Yes?
I'm not able to find my API key.
You can just use mine.
Okay.
That's fine for now. So mine will work. Any API key will work. That's a problem because if you kind of get to steal an API key from anyone, you can just use it because there is no other authentication process. If you have the API key, you have access to what the API key allows, right? Okay, so I started now. So you may ask yourself, why --- file? This is what the UV people decided to implement, right? So if you want to get used to more commands of UV, I recommend having a look at, I linked it in our Nextcloud share. If I close this, there's online resources. And there's, for example, a UV cheat sheet, right? The most basic commands explained. And if this is not enough for you, you can deep dive into the whole documentation from UV, which are several hundred pages, kind of. So, but in the end, what we want to end up with is a rebooted JupyterLab, which now we want to check whether our environment variables we provided in the secrets file are available now, right? So let's check. We reopen. Anyone? Still more problems before I go on? Looks good, great. We open session 1, Notebooks, AI Assistant Basics. I saved the current state of my notebook, so I can now rerun this code cell and check whether endpoint URL, which provides the URL to the API endpoint, is available right now. And ta-ta, we have this environment variable stored and available in our environment. So this means if we can read it, bia-bob can read it, right? So you may also check for the environment variable OpenAI API endpoint. You can just copy paste the name from down here. And here it shows your actual API key, which is now available in JupyterLab and can be read by our AI assistant. So, but if you take your time, like revisiting the notebooks in a couple of days, everything I just told you is described and written down here in the markdown cells, right? So it's explained, hopefully in enough detail. You may encounter this UV run and -file path to secrets. This path to is, you have to take it literally because I don't know where your secrets file lies, so you need to complete the path. Is it the same folder you can omit path to, but is it under C _user _my name _downloads, then you need to provide the full path, right? That's this path to. Okay, like I already said, you can check for yourself whether endpoint URL and OpenAI API key is available. And if you have this, you are fine to go to load bia-bob and use it. And this is what we want to do now. Okay, what you encounter in the next code cell is basic Python commands for incorporating additional libraries, right? This is import. Import OS means import the library operating system, which helps reading environment variables. And we use, we call bia-bob, which is another Python library. And from bia-bob, we import bob, available models, fix, and doc. So I just leave it here. Please run this code cell that it's actually get executed and everything gets imported. Sorry? Exactly. Yeah. So code cells are grayish, while markdown cells are white once executed, right? So, and we can now go to the next code cell, which says Bob initialize. Bob initialize does the following: take our AI assistant Bob, initialize Bob with for the endpoint written down in the environment variable endpoint URL. So right now, if we execute this cell, you get cell output, and if you read it carefully, you will encounter the information bia-bob now uses endpoint https LLM.ai, stuff like this, right? So this is a sign for you, okay, bia-bob actually took up the content of the environment variable and connected to the endpoint from e-infra metacentrum.
Can you hear me?
Yeah.
I didn't catch. What should I do after I put my SK?
You need to save it, right? So it's saved already.
Control S. You did or?
Yeah, Control S, or you can also do something like File, Save. All right, it's just, and now you need to reboot. Once you change environment variables, what we did right now, you need to stop JupyterLab via File, shut down, way to the down. No. It's here, shut down. Every time you change an environment variable, you need to reboot JupyterLab completely,
Close
right?
and open again.
Exactly. Shut down. So you may close this again, and then you need to, wherever we were, I'm not quite sure which PowerShell is the one, right? And then reboot JupyterLab again. Okay, yeah. I'm so happy we planned plenty of time. Actually, really.
I have error here.
Okay.
Also.
Yeah, exactly. This means somehow the secrets file did not load properly. So it's not provided in your JupyterLab. We can just check. We have secrets. This should be fine. So we now need to check why it didn't load. So we need to shut down properly. We can close this, gets reopened. Now we need to open our terminal again. Which one is the one? I assume this one, right? So we can now check again whether secrets is here. And we now want to run, which you already did, I assume, right? Here we are. Just it's the basic thing. Have you put it out and on again? So this something like this. Yeah. Sorry.
It's frozen, so I.
Oh yeah. The point is somehow you did not use this copy paste icon. I assume you. This is those are special characters which do not work, right?
Okay.
So we need to. So there were unexpected special characters in your secrets file which JupyterLab can't handle. So you need to shut it down again and reload with this.
Okay, so.
Oh. No. Shutting down JupyterLab is here.
Okay.
You can do File, Shut Down. Shut down. So this is gone. You can close this tab. Now go to the terminal and then just rerun this command with uv run --env file secrets. Oh, there's no autocomplete. Okay, we are not in the correct environment. You called secrets MD. This is what I told you. Can't there don't have to be a file extension. It's just secrets, right? So maybe in your file browser, remove the file extension. Kind of rename.
Rename.
And we just going to remove this and yes, and now run this again. Just up. And this should work now, hopefully. Yes, and you can now check within this AI assistant basics. If you run this code cell again, it should show an environment URL. Anyone else with problems right now? Save your work. I'm not quite sure what. Yeah. Somehow they got introduced by during the copy process, right? So this should. So we want to put it down again, and we want to reload it. Here we are. Hopefully. Yes. Okay. So, okay, hopefully we are on the same page now. So, for those already having Bob initialized, you can see now, okay, Bob is initialized with the according and correct endpoint URL. Why don't we have to provide the OpenAI API key specifically? This is something which is implemented in bia-bob. It already looks for an environment variable named this way automatically, so we don't need to provide it, right? This is something bia-bob catches up automatically. We just need to provide the endpoint URL. And now we can do stuff within the code which you may already check, also check on the Metacentrum website, where you can just read the website and read which large language models are available. But bia-bob also provides such a method, which is called available models. And if we execute this code cell, it reads the remote provider API endpoint, gets all the available large language models, and we just display number 10 to 20. There are way more, right? So for example, there is a model Kimi K2.5, which is quite a large one. And there's also a model Mini. Mini is a synonym for an underlying model, which is a bit smaller, but quite fast and fine for simple question answering. So for now, we want to work with Mini because it's quite fast and yields result quite fast in a way good quality, right? So how can we tell Bob to use the model Mini? We can just initialize Bob again. You can initialize Bob as often as you want with different values. What we do right now is Bob initialize, we tell them to which endpoint, and we tell them the model name. And if you execute this cell right now, if you read the small text in the cell output carefully on your device, it tells used model Mini, vision model none, which is fine, endpoint HTTPS, LLM, E-infra, blah, blah, right? So right now, bia-bob is set up with the correct endpoint. It uses the correct API key, and it will use the model Mini once we start prompting. And this is what we want to do now. So, okay, so scroll down. There are two ways for prompting Bob in a code cell. We use the magic commands, this percentage sign, and there are two types of magic commands, right? A single percentage sign, then Bob without any white space, and then there's a single line prompt. All needs to be written in one line. This is one way to prompt. This is just how it's implemented, right? We don't need to take care of this. What we will use, which I prefer and recommend to use just anytime, is double percentage sign, Bob, new line, and then you can put as many lines as you want. This is a multi-line prompt. And we can just test this. In the following code cell, we have percentage Bob. This tells JupyterLab, okay, take Bob, bia-bob, and here's the prompt which should bia-bob take care of. And then you can ask questions. Hello, are you familiar with machine learning? Please explain briefly. Just short text output, no code, nor code cell, right? And if we execute this, what's happening right now, this prompt gets sent to bia-bob. Bia-bob reads the API key, reads the endpoint URL, and sends this prompt to the LLM hosted at e-infrastructure, gets the answer back, and displays the answer in a cell output. So we now have incorporated a chat-like question answering with a large language model via an AI assistant in our Jupyter Notebook, right? Question?
She found it there.
Okay, great. Help your neighbors, of course. So you may now encounter that your answer differs from my answer. And this is inherent to large language models because randomness is an inherent feature to large language models. They are not deterministic. The same output given several times will result in different results, right? Or in different answers. So your answer may differ from mine. I may also, and this is prompting now, I may also adjust my prompt and remove no code and this short text output. If I remove this and ask this again, then bia-bob will probably also provide a couple of code bits to explain how machine learning can be used in Python, depending on the model. Here it does not, but if I ask several times, it may end up with auto providing code. And you will see the answers differ from your neighbor, from your last prompt, whatsoever.
Just a question, why is there a space? Is it some sort of convention?
Oh yeah, if you, and that's a problem, this AI assistant library isn't perfect, like all the AI assistant libraries for JupyterLab. If I remove this white space after the question mark, right? This one. So then I may get an error sometimes, or it's okay. In former versions of bia-bob, this kind of was interpreted as a Python object and learning is not available, and then there was an error message, right? So if you encounter stuff like an error message, try put white mark or white space between question marks. So, and as you can see, I ask it again, the answer differs from before, stuff like this, right? So we now have question answering integrated in our Jupyter Notebook, which is quite nice. Okay, next step would be providing context for our AI assistant. Right now, the only information our AI assistant has is what I have written into the prompt. But we can provide context. In our case, we want to provide the content of a variable we defined before. If I scroll up again, this is what we did before. We ask for available models, which is a list, and we stored this list in the variable called models. And then we just printed this variable. And we can now provide bia-bob with the actual content of this variable by using curly brackets or parentheses, right? So if we go down, this is so-called prompt augmentation, to augment something, extend by more context, right? So we ask again, or we prompt our AI assistant again. Now we want to have more information, or there are so many large language models on the server. I don't have any idea when to use which model. I don't know. And I don't want to crawl the whole website by myself. Just explain to me, please. So I'm going to prompt bia-bob for read the names of the large language models provided in this list. And now, parentheses, put the variable name in there, and bia-bob will automatically read the list stored in this variable. And then for 4 models of your choice, explain what each model is capable of and when I should use it. And if I execute this, Bob reads this list, extends, augments the prompt accordingly, and then randomly picks 4 and explain what those models are and how they can be used. And if you execute this prompt, you may get 4 large language models explained, which may differ to your neighbor's large language model explained, because it randomly picks 4 from the whole list, right? So this is what this prompt augmentation is. It allows to put actual content from your JupyterLab notebook into the prompt without writing it down. You just store it in a variable and then provide it. And here, context length for the context, or maximum length for the context window will play a role. Just imagine this list of model names has 1 million words. then we will reach our context window length maximum, right? So we need to take care of what we put into such a variable and what we provide to bia-bob. You may just play around with the prompts, yeah? Rephrase the questions, ask something else, actually, what you are or what you want to know, and then just see what bia-bob answers. In my case, it just explained 4 models and when I may probably want to use it. And here, be careful. It's a large language model answering you, right? Large language models have a knowledge gap, right? So if there's a model which was introduced after the large language model we used was trained, the large language model does not know about this and may hallucinate and may just make up facts to create an answer. But this is kind of something you may be aware of when using large language models. They are not accurate 100% of the time, especially if it's up to where making up facts may blend in without you realizing, right? Okay. Any questions up to here regarding initializing Bob, prompting Bob, and putting more context into a prompt by augmentation using these curly brackets? Any problems up to here? Okay, so now we want to use Bob to actually generate code, yeah, which may help us for data exploration using Python, stuff like this. If we scroll down a bit, there's in text explained what bia-bob is capable of, right? So we can use Bob to generate code. We can use Bob to explain code. We can also use Bob to put comments into a code cell which does not have any comments yet to help understanding the code. Yeah? Let's try this out. First of all, you will see this code cell which is commented, which writes UV at pandas. We will not execute this yet, right? I just want to show you how you can use UV within to add additional libraries. So what we want to do is we want to prompt Bob to please generate Python code which does the following. Create a list of 10 random numbers, floats, compute the mean and the standard deviation, print the results, make use of the packages NumPy and pandas. NumPy is numerical operations in Python, and pandas is this library Excel-like handling tabular data. And we give this specific command, just the code, no comments at all, right? If we execute this cell, bia-bob is now sending this prompt to the large language model. We get the answer back. And if we explicitly ask for code, bia-bob will just add a new code cell to our notebook, which can be executed right away. This is what it generated in my case, which is quite nice. So now I want to execute this code cell and see if it really creates 10 random numbers and if it really computes the mean and if it really prints the result. And if I execute this, I end up with an error message, right? So what does that error message mean? No module named pandas. This means I want to make use of a Python library which is not installed in our virtual environment. And happily, we can call UV to add this library right away from our notebook. And this is what this code cell above does. If you just uncomment it, we have this exclamation mark UV add pandas, right? So we have UV sync, which reads the result and does all the stuff. But we can also tell UV to add a specific library, in our case, pandas. Yeah.
Is it this time or not? Maybe I got lost.
Wait a moment. No, this is another error. This is something from the large language model, actually. We need to check.
I just execute.
Rate limit. Ooh. Did you use your own API key or mine?
I think I used yours.
We may just check. If I encounter the same problem right now, then there are rate limits. Okay, so right now we have an actual error message from the large language model backend. She just executed a prompt, and the error message is, you hit the rate limit for your API key. So this means for today, I don't know, no more prompts are allowed using this specific API key. So right now we can't use this API key anymore, but I'm not quite sure if this also applies to me. We will see.
I think I didn't change the API.
Yeah, which is fine. I
This
actually.
one's yours.
Yeah. Actually, but but I actually just didn't thought there's a rate limit for basic prompting. We just did you run it several times?
Yes, I tried it twice.
Okay, so there was just kind of an error in the backend. So hitting it once again and once again and once again. Yeah. So but this worked. A number here is showing we have a result, and here you have your code, right? Yeah. Yeah, sure. Yeah, just tell me. We can, of course, have 5-minute break right now. Sure. We may also open the windows, probably. Okay, welcome back from the break. Since we only have 20 minutes left and a couple of time was needed to fix the problems on the laptop, I will skip a couple of parts regarding how to interact with code. The main point of this was to show you how you can interact with the AI assistant, right? But that wasn't the interesting part. Yeah? You may ask yourself, how does this help for data steward tasks? So I will move on, just show you a couple of bits, and then we will use our AI assistant to draft kind of a data exploration plan, to draft content for a data management plan based on data exploration, and to really draft a complete Jupyter Notebook with visualizations and stuff like this, which helps analyzing, exploring data you just was handed over with, right? So this is something I want to show you right now. I recommend to read the notebooks again. All the text is explaining what I'm now skipping. But this was up to here. How do I interact with bia-bob, which helps creating or answering questions and also creating code cells which can get executed. So I would like to ask you, I'm going to show you, but to ask you to open the third notebook, AI Assistant Advanced. Right now we use Jupyter or we use bia-bob and the underlying large language model as shipped from the provider, right? But there's something called system prompt. I'm not quite aware if you are familiar with this, but a system prompt is a prompt you can just put in front of every started conversation, which gets handled in a way that it defines the basic tone and quality of the large language model. So this is additional context for your specific conversation. With this system prompt, you tell the model how to behave, how to answer, and which additional knowledge or context plays a role for your task, for your conservation. So with the system prompt, you are capable of creating your domain-specific AI assistant. This one right now is quite generic, like this mini model, whatever it is, and bia-bob, which has kind of a tendency to be a bioimage analysis assistant, right? We remember, but we want to have a data steward assistant. And this can be done by a system prompt. I just show you what this notebook does, right? If we import bia-bob as usual, and we can just check which default system prompt bia-bob is shipped with. This is this bio-image analysis data system prompt. If we put it out, there are stuff like, you are an extremely talented bio-image analyst and you use Python to solve your tasks unless stated otherwise. This is the system prompt bia-bobs is shipped by default. We want to change this because what we want is, you are an extremely talented data steward assistant, right? Because this would help us way more. This is helpful context for our domain-specific application of bia-bob. So we can initialize bia-bob with our own system prompt. In this case, a very simple one. You are an excellent Python programmer who always puts a smiley comment at the end of each code cell, right? We can initialize bia-bob with this and now ask bia-bob to generate Python code, a for loop which prints the numbers from 0 to 10. And hopefully, depending on the model, we will end up with a code cell doing this, right? And here we have our smiley comment. So our system prompt defines the tone and the behavior of our large language model. It always depends on the large language model. Some large language models have a very strong so-called alignment. They do not differ from their initially trained behavior. Some are more aligned, some less. For example, I also tried to, you are an excellent Python programmer who always puts a pirate joke at the end of each prompt or answer. This did not work because the large language model does not allow such a behavior, for example, right? But here you see we can define the behavior and additional knowledge of such an LLM, of our AI assistant, with a system prompt. So knowing that we can force our large language model to put smiley comments on it, we can also force it to be a very, very helpful data steward assistant, right? So we may write a system prompt which defines what a good data steward assistant is. And we don't need to do it by ourselves. We can just ask Bob, hey, please write me a short but precise system prompt in Markdown format used for an AI assistant, blah, 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 right? And it should please store this system prompt in a Python variable called system prompt data steward. So this is running right now, and the output would be something, a couple of paragraphs of text defining what a good data steward assistant is. And we can, so this is what we end up with, yeah? So there's a data stewardship assistant. The role is to provide expert guidance on institutional and project-specific data stewardship tasks, blah, blah, blah. We don't need to read all this, and it still puts a smiley comment on the end, right? So we can just alter this output that it's a proper code cell, execute it. Now this content is available in the variable I'm just showing you. And now we can re-initialize bia-bob with this created system prompt. And now we ask bia-bob, hey, who are you? And we should end up with an actual helpful data stewardship assistant, which has additional knowledge provided via this system prompt context for data stewardship, right? So it may help you with data management plans and all this stuff, right? So, yes?
Maybe stupid question, but why is there a gap between you and the question mark? Is it something specific or is it random?
No, it's something specific because this is Python specific. This is still a code cell, and if you have an object, which is the word you, and it has a question mark on it, this is Python syntax for explain what this object is, but it's not real Python code, that's why it's a problem. But it's just for the question mark, right? So, and I already provided you with a very, very extensive system prompt for data stewardship. You may have a look at in your secrets file. Right? If you open the secrets file and scroll down, you will find system prompt data steward. This is a data steward system prompt crafted with Claude and iterated several times, and it's like 2 A4 pages, kind of, right? And you can provide everything here. Always keep in mind the context length maximum, but you can provide, for example, If you use Python to draft any code, just use those and those libraries. If you use R to draft code, use this and this libraries. You can ask the AI assistant to draft R code too, right? You should please always prefer authoritative primary sources like EU, Horizon, whatsoever. And you can put all this into the system prompt. And this is predefined in our secrets file right now. And you will end up with this at the very or nearly the very last code cell in this AI Assistant Advanced. This is something you can use as a template for our sessions. If you put this at the very beginning of each notebook to import and initialize bia-bob, you always have this data steward specific AI assistant at hand. If you execute this and then ask bia-bob who you are, the long version, you will end up with a really, really long description of what bia-bob is capable of and may support your work with, right? So fair alignment, operating principles, blah, blah, all this stuff, right? Tool usage, programming languages, key constraints, whatsoever. So we now have prepared a domain-specific AI assistant, which we can use in Jupyter Notebooks, right? So, and now comes the fun part, like actually using it, right? So, any questions for system prompts and how to steer the behavior of an AI assistant large language model? Great. So now let's open the last notebook for today's session. Yay! It's DS workflow, data steward workflow. I also provided you with a small file which is under data, and there's research data collected for penguins, right? There's a CSV file where lots of researchers collected field data for penguins, and this is the data we are provided with. And what we want to do is ask our AI assistant to support us with data exploration to understand the data and then help us drafting a data management plan on how to handle the data and also draft a full Jupyter Notebook which does the data exploration with visualizations and stuff like this, right? Okay, so let's start with our first code cell, which is always importing bia-bob again with all those information, especially this very fine-grained system prompt for data stewardship. Okay, one use case may be, okay, I have data, somehow I need to explore and validate the data. I want to write a data management plan based on the findings, but I don't know how to start. Maybe I just ask our AI assistant, okay, what would be a good plan for data analysis and going on further? And we can ask bia-bob, for example, I have data in a CSV file, I want to explore and validate the data, I need to write a DMP, what are the steps and tasks I need to consider? So this is just question answering, but now I don't want to have it as an output of a cell. Bia-bob is capable of creating and storing markdown files. So we ask specifically for a file, which is an artifact we can include in any reporting stuff, right? So if we execute this cell, you will get the message, the file has been saved as my plan. So, and if we open our file browser, you will see, oh, there is actually my plan was created. So I can do right click and open with Markdown Preview. And here we see a complete data exploration and validation plan. What are the steps I need to do and when to do it and what are the results, right? So bia-bob, or our data steward assistant, can help you planning stuff, right? So also it tells you about, oh, data quality assessment. You may check for missing values. You may check for duplicates in the text. You may check for outliers or inconsistent formats. You need to validate against metadata. So it's just explaining you the steps. And all those steps are already stored in my plan. Okay, so now we want to actually tackle this whole data analysis plan step by step, right? You may ask Bob, like, like shown here, to generate Python code in a code cell which does this. But we will skip this because the last part is way more interesting. We will ask our AI assistant to generate a full Jupyter Notebook. And for this, we may want to use another large language model, which is more specialized in coding. Right now, we use Mini, which is more like question answering. But now we want to use the large language model with the synonym coder. You can find which large language models are available on the e-infra Metacentrum website, right? So we want to re-initialize bia-bob with this other model, which is this code cell. Here you can see Bob initialize, same endpoint, but now we want to use the model coder, which is a large language model specialized in writing code, right? And now we ask our data steward AI assistant, okay, please generate a Jupyter, there's a typo, Jupyter Notebook called Penguin Data Exploration, which does the following. Read the file which is stored in this and this folder. Explore the data properties and statistics, include missing values and outliers, visualize basic data distributions. Do not, and this is the important part, do not just, you may not just ask what the AI assistant should do for you. It's also very helpful if you state what it explicitly not should do, right? And we do not want our large language model to assume any values. So we want to kind of get around this whole hallucination problem, right? We want a very good structured notebook, that it is clear and self-explanatory. The AI assistant should also include markdown cells which explain what is done and why it is done. And at the very end, it should provide a summary of the exploration which can be put into a data management plan, for example, right? So let's execute this. This may take a bit longer because the underlying large language model coder is a bigger one, a more sophisticated one, and I hit the rate limit. Yay! So this is such an error, which is an actual error from the large language model backend. I just got told for my API key, I hit the rate limit. I'm not allowed to ask any more questions for today, but sometimes it helps to just rerun and rerun and rerun. And it looks good right now. So, and you already see this takes way longer because the model is more sophisticated and the task is way more complicated because it needs to craft a full Jupyter Notebook doing all the stuff we asked for. And it's still working. So, and just for your information, this is specific to bia-bob. Bia-bob is capable of reading and writing markdown files and Jupyter Notebooks. You can also ask bia-bob, hey, I have this Jupyter Notebook, read it and make any recommendations on how to do it better. This works, but it can't handle like docx files or Excel files. But bia-bob may create code which can read Excel files and transform it into markdown, for example, right? Did anyone execute the code cell too? Are there results yet? Yeah, okay. So it's probably really kind of a rate limit, unfortunately. So, but whoever was able of finishing or really getting an answer, there should now an additional notebook named Penguin Data Exploration show up in your folder, and okay, yeah, if you hit it twice, then yeah, and you can open it and execute all the cells and just check whether it works or not. It should work. Why doesn't it work for me? What's a pity?
So you want us to execute the first cell?
Bitte? Sorry?
You want us to execute the first cell?
You can execute the whole notebook if you want to really explore penguins, kind of. So in the end, this notebook is meant to do the following: really opening the file which exists in your folders under data, Penguin data. And then the notebook does all the data exploration, check for missing values, plot data properties and distributions, write down why each and every step was done or not, and in the end, give me a short summary of this whole data exploration, which I can put into a data management plan, right? And I even can ask bia-bob now, with those results in this Jupyter Notebook, please give me a markdown file for this specific, here we are. Great, I just need to talk long enough. Okay, so this is my Penguin data exploration notebook, which does all the things I just talked about, right? There are lots of code cells. Here we are again. Moldu not found, matplotlib. Matplotlib is a library for plotting stuff, for like drawing graphs. Here we already, I just want to show you that it works, right? We want to add matplotlib, and we also want to add Seaborn, because this is something. So this should work now. If you run it the first time, there may be some caching processes which take a bit longer. So, but now I can do all this stuff. I can load the data and plot the first couple of lines to have a look at it. And this is all code. I did not write it. bia-bob did write it and put it into a notebook, which I can use, right? We can do some data profiling, like computing basic statistics of the data. We can analyze for any missing values. For example, the column comments has like a missing count of 290, which is about 85%, which is an important information for data quality, right? We can do outlier detection if there are any outliers, obviously not. Nice. We can visualize data distributions. All this done in this notebook created by our data steward AI assistant. And in the very end, it helps us summarizing all those information which we can put into a data management plan, and you can just copy paste it for this very specific data set we just used, right? And now at the very end, you have this wonderful notebook doing all the analysis. You can even do the following. This notebook is browser-based. You can export it to HTML and provide any other person with a complete HTML file. You can also print it to PDF and put it to any reporting regarding this data exploration. So here we are at the part where our AI assistant really becomes helpful, kind of, regarding data stewardship tasks like loading and exploring data, summarizing data for a data management plan. We then may export our Jupyter Notebook, this notebook, which was created, to a PDF, and then put all this into a package, attach it to the data management plan, and we are fine with those tasks, all supported by our AI assistant in JupyterLab. Any questions up to here? I'm quite sure this was quite in a hurry, those last 15 minutes, but I'm also sure you are tired right now. So any questions up to here regarding this?
I wonder why my generated Jupyter Notebooks only contains the introduction and nothing else.
And this is, okay.
Based on the same prompt, and it's just this.
Okay, then you may just delete it and rerun the prompt. Okay. So here we are. Large language models have randomness, and sometimes the answer is not complete, sometimes the answer gets cut, sometimes the large language model thinks, oh, I just need to put a markdown cell and then I'm done. So this is, you just rerun the prompt a couple of times and maybe rephrase the prompt and then hopefully get the results you are looking for, right? But this is working with large language models, especially the smaller ones running on European servers aren't that capable compared to ChatGPT or Claude or whatsoever, right? But in the end, to wrap it up, I wanted to introduce you today to what JupyterLab is, how you can start JupyterLab on your laptop using UV in a reproducible environment with this PyProject. I have shown you what Jupyter Notebooks consists of, this different type of cells. I have shown you how you can include bia-bob as an AI assistant, how you can define the behavior of your AI assistant to be more domain-specific helpful, especially for data stewardship, and how to use bia-bob to really draft artifacts like Markdown files, JupyterLab, Jupyter Notebooks for data exploration, stuff like this. I really hope that helps. I really hope that session was kind of interesting and not that tiring. If you have any questions more, I'm still here for like my session tomorrow, of course, but I'm also here this evening. I will leave tomorrow after lunch. So in this time, you can just ask any questions. Hope you had fun. Thanks. And also, I really encourage you, just start from scratch at home, download the notebooks again, this without any further addition, and just read through, try around, work on them yourself. It really helps to get comfortable with the tools, right? Okay.